So we already saw there are lots of things that can be done, yeah, to have sustainable computing, yeah. I think I just did put this question, what extra can be done? So again, we do not have the text box, yeah, but if you think something that we have not discussed, just you can tell, yeah. Anything you think we have not covered? No? I'm looking my notes just to see if there is anything missing. So we already have covered carbon reporting, yeah, for transparency. So every organization should report how much carbon they are burning, yeah. And cooling and environmental controls, yeah. We have already seen we should not cool more than needed, yeah, or we should not use more than needed energy. I think we also discussed human and process factors, yeah. So humans should be trained, yeah, all regular training is required. There could be also some green procurement policies, yeah. For example, some companies, they advertise, right, their TV takes less power, their refrigerator takes less power. So typically people tend to buy those more, right? So similarly, they can be a bit expensive, but that's better way to do, okay? And there can also be continuous improvement, yeah, there could be periodic audits. So once you report your carbon footprint, it should not be just once, yeah, there should be periodic, otherwise just when you are reporting, you can take care, but not before or after, yeah. And there can also be something called like feedback loops, feedback loop for design and operation, yeah. So for example, let's say you design the system, yeah, and then someone can feedback like what can be improved, yeah. For example, the smartphones, right, all the smartphones for all the kind of people, they are designed in the same way, but if you look different people who are fall into different age category, like the children, like then you can say young people, then old people, yeah. Old people want to use phone in a different way, yeah. They do not want so many apps, yeah. It's mainly for them to communicate, yeah. So I mean there can be some kind of this kind of feedback loop, yeah. So there could be phones maybe much cheaper with less resources, and this can be phone for old people, yeah, and their font can be bigger because they don't see it very well, okay. For children again can be different, yeah, maybe already secure or something, yeah, like they can't use every website, they can't use every software, yeah. For adults, I think it's like the one that is produced, yeah, and everybody is using. So there could be some feedback loop, like what kind of device is more useful for what kind of people, okay. And we can also do some benchmarking against industry leaders, yeah. So there are some industry leaders who work into like renewable energy or carbon efficiency, so it's always good to give the examples, yeah. For example, electric vehicles, yeah. So if you know Tesla, yeah, they were very ahead in the race and they got lots of profit as a kind of carbon efficiency credits, yeah. So they make a lot of money from that, yeah. So those kind of examples are good, okay. Okay, now key takeaways for sustainable computing from system design and operations point of view. So always try to design smart and always try to operate smarter as well, okay. And sustainability is both a technical and cultural shift, yeah. It's not just we make the computer very sustainable, yeah, it's also about culture, yeah. We should try to use them as much as possible, we should try to turn them off, and there could be some inbuilt mechanisms that can always make sure it does not use a lot of power, okay. And also device should last longer, okay. So you can say the future can be carbon aware scheduling, yeah. So always be aware of the carbon in using the resources of the electronics, circular hardware economy. So, it is like when something gets faulty, then how it can be repaired, if it not, how it can be refurbished, if not, how it can be remanufactured, and if not, how it can be recycled. So, nothing goes a waste. Okay. Yeah. And some of the industries are already doing it, like construction industry. Sometimes if a building is old, it is kind of demolished, but there are mechanisms people extract useful parts, so, or like reuse it in kind of some concrete or mixture or something. So, similarly for this one can be done. AI optimization is another kind of future. Most of the carbon you can say is burnt to kind of run the AI workload on the hardware. Yeah. So, what can be done around it? Okay. Okay. Any more questions? No? Good. So, hopefully this gives you good idea to kind of have introduction of secure computing, sustainable computing, and what can be considered when you design them and when you operate them. Okay. Yeah. Good. So with this we come to the last lecture of mine today. There is another lecture, yeah, by Dr. Momita after this. I think some of you were interested into communications, yeah. So that lecture will cover that. So it's good, like you can attend that. So in this one we are going to cover computing systems of various scales and their design challenges. Okay. Again, these design challenges we are going to look only from the cyber security and sustainability point of view, yeah, not everything. Okay. So we already have seen this, right? So what is the typical computing systems landscape? Yeah, we said we can have billions of edge devices, yeah, or sensors, small processors. Then we can have millions of servers, yeah, and there could be thousands of data centers. Okay. So this is one way to kind of categorize, you can say this is the computing system landscape, but there is a kind of another more formal way. Okay. So before going to that, let's look like importance and challenge of scale in design and operation. Okay. So what is the importance of different scale? For example, the edge, yeah, and the servers and the cloud, and what are the challenges into those if you in the design and operation phase, if you want to care about the security and sustainability. Okay. So again, I think I have put a question, what are computing systems of various scales? Yeah. So we already have seen like this, yeah, but this can be kind of further have more fine grained categorization. Okay. So for example, one category can be IoT sensors and embedded devices. Yeah. So this one will fall into that. Yeah. Another can be edge computing systems. Yeah. So edge is called typically you do the processing near the sensor. Yeah. That is why it is edge, or somewhere in the closed premises. Yeah. Don't send the data to cloud. So edge can be again same embedded device, or if these servers are very close to these sensors, then also it is an edge. Okay. The third category can be high performance computing and supercomputers. Okay. So again, these can be a set of servers, yeah, and we are going to look in a bit more details, yeah, and supercomputers can be designed based on that. And the last one can be cloud and large data centers. So this category, yeah. Okay. All right. So now I have put a question, yeah. So can you match here to the right category? So you have a television, a smartphone, PlayStation, camera, this recorder, a car with lots of electronic, and a data center. So which one you will say is IoT sensors and embedded devices? Yes, you can say, yeah, like that, yeah. But I would say maybe this one has a camera sensor, yeah, and lots of processing is done there, right. You can see some camera with motion detections and all those, yeah, that is processed at the edge, yeah. And then this one also some processing, filtering is done. Here also these days cars have several cameras, yeah, and the decision is done there, okay. Phone also has a camera, yeah, but phone also does a lot of processing, yeah. If you kind of consider old age phones, they were not powerful. So I would say nowadays phone can be into edge computing as well. There's lots of processing is done on the phone, okay. Okay, what about cloud and large data centers is very clear, yeah, is this category. What about the high performance computing and supercomputers? I think I would not say PlayStation. I would say PlayStation is again like edge compute, edge, yeah. You do lot of control, but then decision is made locally, yeah. I think we will come to the definition of how first we can define high performance computing, okay. And then you will see like, so this kind of thing can be done in a set of servers, but it doesn't have to be cloud scale, yeah. Cloud has like so many servers, yeah. So this can have a limited set of servers where high performance computing can be done, but this can be done in the cloud as well, okay. So I would say there is very thin boundary between these everything, yeah. So lots of people can say this is just one category, yeah, and some people can say this is just one category, yeah. So you can say that there is only two category, yeah, okay. We will see like the boundary is very blurred, yeah, we can't really say. But if someone says like, okay, what categories you can think, I can think of these four, okay. Okay, so first let's look IoT and embedded systems, the first one, we said 4, right. So this is what is IoT and embedded systems, yeah, we are surrounded with, and these are in billions in numbers, and these are small scale devices with limited resources, yeah, and used in smart homes, wearables and sensors, yeah. Now what are the design challenges from cyber security point of view? So you can see these have limited resources, yeah. So you can only do limited processing, yeah. So if you want to do some kind of advanced encryption or decryption, there is not enough resource, yeah, or you cannot put a very heavyweight software on it that has to do some kind of detection of malware or preventing it, okay. They are also difficult to patch or update, yeah. So again the reason is not they have limited resource. If you keep doing updates, the software can be very heavy, yeah. So that is difficult, and physical tampering risk is there as well, yeah. So like I said, someone can take my device, my phone, and then they can reverse engineer to get some of the data, okay. About the design challenges on sustainability, and these are some listed here, but you can think of more. So the first one is battery waste and disposal, yeah. So that's kind of one challenge, and short hardware life cycles. So if you consider these small scale electronics, they typically do not have high life cycles, yeah. So they do not last for a long time, okay. And they also have resource intensive manufacturing because they are produced in billions, yeah. So many of them need to be produced, okay. So this is just one kind of case study example, IoT and embedded systems. So this one is from cyber security point of view. So this is Mirai botnet, you might have heard about it. So botnet is kind of a network of devices, you can say IoT devices, but each of them has been a kind of hijacked by an attacker, yeah. That means each of them has been made corrupted, okay. So if there is insecure network or insecure IoT devices, this kind of things can happen, okay. So this is kind of a popular attack that typically happens in a network of devices, okay. This case study for security and for sustainability, you can say sensor recycling is used in smart city projects. Yeah, so you can see like sensors are placed, yeah, but they have a lifetime. Yeah, after some point they need to be replaced, but they are just thrown away. Yeah, there is no recycling. So that kind of recycling can be done basically to have some sustainability considerations. Okay. Okay, edge computing systems. So I am again putting the same number, same basically devices. So like I said, there is a very blur boundary between those. Edge is just like there is more processing at the edge. Like I said, phone can be edge example, but a camera can be like IoT and embedded systems. Okay. So you can say in a way this is intermediate scale between IoT and cloud. Yeah. So it just sits in the middle. Okay. So like this phone is receiving some sensor data like my voice when it has to do something, or something in the camera does some local processing. Yeah. And then it doesn't rely always on the cloud. Okay. Because there could be some app that can do the processing of the image. Okay. And these process data closer to the source. Okay. That is why it is called edge. Yeah. Okay. Cyber security challenges. Yeah. I think these are again something similar. So physical access threats, like I said, someone can access. There could be distributed attack surface because there are so many and they can be connected. So again similar example, yeah, that's Mirai botnet, that kind of things can happen here as well. These have remote management complexity, again due to limited resources, you can say, yeah, not easy to do that. About sustainability challenges, I think about similar like the previous one, because there is limited resource, so it's not easy to balance the power and performance. Yeah, you cannot achieve a lot of performance because there is limited power. Yeah, and in these kind of devices you need to do cooling in small enclosures. Yeah, imagine this phone. Yeah, if it becomes very hot, the cooling has to be done in this small place. Yeah, you cannot put an AC to cool it. Yeah, that's very expensive. So you have to think all these. Yeah, when this becomes hot, how the heat is going to be released. Okay, so these are the challenges. Okay, so now edge computing system case study example. So this is kind of a question. Can you think of something? So this could be again like from cyber security point of view and sustainability point of view, both. Yeah. Okay, so don't worry, let's look just. So any industrial AI deployment, yeah, that is balancing latency, energy use and doing secure data handling, it's basically case of edge computing. Yeah. So you see like when there is some industries, a lot of manufacturing is happening, there is a checking points at each point. Yeah, like whether the mixture has been mixed nicely or not, and after that something has, a component has been manufactured, whether that has come nicely or not, then it is assembled, whether assembly has gone right or not, then there is some kind of other follow up testing or checking. Okay. So in any industrial AI deployment, there is lots of local processing. You see the process and you take the decision whether it's right or not. Yeah. If something is wrong, you discard the device because later on it's not usable. Okay. Okay. So now I have put a question, can edge computing systems include servers as well? On-premises servers. Yes, that's right. Yeah. So you have to use on-premises server. Yeah. So for example, like in IIT Guwahati, yeah, there could be few things, few cameras or something. You do local processing, but you send the feed to some local server as well, and then you do the processing. So on-premises servers, you can say this is edge processing. Yeah, it's not cloud processing. Okay, good. So it can be. Yeah. Now let's see this high performance computing and supercomputers. Yeah. So how exactly you can define it? So these are massive scale systems for scientific computing. Yeah. So scientific computing is like some people are doing simulation of the earth, yeah. So by that they can know like what is the life of earth, what will be the temperature of the planet in 10 years, yeah. Or some people are simulating like whole human life, yeah. If you have to live like 100 years, what you should do and all those kind of things. So this is basically, you can say, high performance or scientific computing, okay. Yeah, so these things can be done in data centers as well, but data centers are kind of for more generic purpose, yeah. So this is more a specific purpose. So the computing center is designed specifically for that, yeah, okay. And that is why these require a specialized infrastructure, yeah, okay. So the design challenges for security, so there is nation state targeting, yeah, because this kind of research is very important. You know, this is one thing I said, but there is also lots of discoveries like drug discovery or something made, yeah. So it's like you put a human tissue, you put some chemical on it, yeah, and you observe how it is changing, yeah, over the time. So then based on that they decide like what kind of compositions should be to make maybe new drug or new medicine or something, yeah. This is how. So lots of people basically, they do not have resource, they kind of want to kind of steal such kind of process, yeah, to know. So so basically this kind of targeting can happen, yeah. If one nation is advancing a lot, others can just try to target it, okay. And this also has issues sensitive research data protection, yeah. So because this is sensitive, so you have to make sure data is protected, okay. And there is insider risks as well, all right. So you might have already seen, I mean, like nuclear, you can say this nuclear machines, yeah, these bombs, yeah. So there is a kind of scientific computing that happens, yeah, like if you do this kind of explosive, what will be the effect if you kind of do this. So you might have seen scientists are being kind of stolen from one country to another to help the war, yeah. So these kind of things can happen. So insider risks is there. Or you maybe some company did some drug discovery, you might have already heard, yeah, like there are drugs coming like for you can say cancer drugs, yeah, or some other very popular, yeah. So if some company is coming first, others just want the formula for it, yeah, or the process that happened in that discovery process, okay. For sustainability, I think it's very obvious, these things take a lot of power and they need advanced cooling, yeah. So this has to be considered, okay. So just I have put a question, if you can think of an example for this one as well, any example. I think before this data centers came, you might have always heard there is this high performance computing center and it is just doing only very specific thing, yeah. So medical companies, they try drug discovery, some kind of environmental scientists, they try to kind of simulate the whole planet, yeah, just like if these activities are happening, or predict maybe when can be the next tsunami, where it can be, yeah, when can be the earthquake, where it can be, what will be the magnitude. So these kind of computing, yeah. So it's kind of very specific purpose, okay. So one example is this one, Fugaku supercomputer. As the name says, it should be in Japan, yeah. So this is one supercomputer and it is ranked high in efficiency despite its scale. So it's like a set of servers for a specific purpose. I think I forgot the purpose, what exactly it was for, but it could be for some nuclear reaction simulations or something, okay. Okay, so the last one, fourth category, cloud and data centers, yeah. So they are centralized computing at a scale and shared by many tenants, yeah. It's like each of us can subscribe to one of the data centers, yeah, or data center resources. And challenges here, there is multi-tenancy risk. Yeah, lots of people are accessing, and in that there could be kind of risk of your password being used by someone else, or like lots of people trying to use the same resource. If there are too many, they may overload the resource as well, yeah, and then maybe no one is served. Okay, insider threats is always there. I think now you might have got the idea. And there is supply chain vulnerabilities as well, yeah. So supply chain issues are always there. You can already see like there are trade wars, yeah. So US doesn't want NVIDIA chips to go to China, yeah. Now I think there is trade war in India, US as well. Let's see where it goes. So, but this is like they don't want NVIDIA GPUs to go there, yeah. So this supply chain issues as well, yeah. I mean one I think the long back even Intel CPUs were banned to be exported to China, yeah, or I think other way around as well. So no, so that is why you can see everybody wants to develop their own facilities, so that the people working there, they do not do something like temper, yeah, something is going fine up to some point and after that it can go wrong. So nobody wants that. Okay, all right. About sustainability, I think it's more or less the same thing. High electricity cost, high cooling cost, and there is issue for the e-waste management, yeah. So electronic waste is a lot. Okay, nothing much here. So for this one, example can be a Google data center, yeah, and they did something nice. I think we already have seen. So they did some AI driven cooling, and that reduced energy cost by 40%. So actually if you look the data centers, there I think 30 to 40% cost is the cooling cost. The 60 to 70 is operating, yeah. So it's like they're running at very high power, it's like so much heat. If they don't cool, then electronics will get burnt, yeah. So that is why the cooling is very, very important. Okay. So now let's see common security challenges across scales, yeah. If you look all those four, yeah, IoT and embedded systems, edge devices, high performance computing or scientific computing, and the last one, cloud, yeah. So these are the common challenges from the security point of view. So patchability and life cycle security, yeah. So patchability is like, you know, there are patches, upgrades and all those. This is always a challenge, yeah. And there is always limited resources at a small scale, yeah. That is why you need to send the processing to cloud versus high value data at large scale, okay. So at large scale, basically you have a lot of data or maybe some sensitive data. So there is a lot of power to process, but a small scale, the problem is we have limited resource, okay. And supply chain trust we have seen in detail, yeah. This is a huge issue. So what do you think can be done to address these? I think some of these we already have covered, yeah. But can you think like what can be done to address these security challenges? So let's say the supply chain trust, yeah, how this can be addressed.
To ensure the authenticity of the supplier.
Yeah.
Background checks.
Yeah, authenticity of the supplier, background check, yeah. So, but there is always in this kind of thing some insider threats, yeah. Some engineer or in that organization and then they pretend to be like normal employee, but they are not normal employee, yeah. They have a purpose to destroy. Yeah. One of the thing could be, I mean, each country tries to have their own manufacturing. Yeah. Data centers or own chip or restricting the chips from their market to go other places. Yeah, yeah. This one, limited resources at a small scale. Again, we can try to process as locally as possible, yeah, so that data is not going away, and so basically you don't need to burn a lot of power in the cloud. Okay. Okay. So these are some ideas. Yeah. So one thing could be you can have in-depth defense. Yeah. Make sure you, whenever an attack happens, you have solid defense mechanism, so that can detect and stop it. There is another direction of research, it's called like zero trust architectures. Yeah. So for example, if you get any chip, any electronics from anywhere, as right, we get the phone, we trust it, we use it, and after some time we realize, oh, there is something wrong, my data has been leaked. Yeah. So do not trust it, then you will do some testing. Yeah. Then after testing you start using it. Okay. Yeah. So typically when an attack happens, then we start thinking, right, how to means let it not happen. Yeah. Let anyone not enter your system, let anyone not be able to install any malware. Zero trust architecture, even if someone has kind of inserted maybe some trojans or something in the design phase, those kind of things. And if you are using any software, do not just install it. Yeah, have some mechanisms, kind of security proof, then put on it. Okay. Later on we are going to see some of these. Yeah, if there is hardware trojan, if there is a software that has a problem, how it can be detected and what can be done. Yeah. So I will introduce some approaches. Okay, so now common sustainability challenges. Yeah, I think most of it we have seen. Yeah, so energy efficiency versus performance, life cycle and recyclability, and optimizing shared infrastructure. Yeah, so these are, I would say, challenges. So what can be done to address these? So let's say you want to achieve energy efficiency, yeah, and performance as well. So how you can do it? I mean, some people design energy efficient hardware. Yeah. So there is something called like application specific integrated circuit. Yeah. So that does only one kind of a specific job. Yeah. For example, crypto mining. Yeah. If you remember, there used to be crypto miners. So that can just do one specific job. Yeah. So kind of designing a specific hardware. Yeah, or also can be like designing a specific software for something. Okay, so not a software that does everything. Yeah, just a specific purpose. Okay, that's one thing that can be done. Let's see what else can be done. So one thing that can be done is modular design. Yeah, I think we have already covered it. Yeah, so you should have multiple modules. If something goes wrong in one, it can be replaced. Yeah. Carbon aware scheduling and computing policies. So we have already seen this. Yeah, when you are using resources, always try to be carbon aware, but there could be carbon aware computing policies as well. Yeah, so governments, policymakers can make some policies like, if the company is selling this many electronics, they have to always kind of report how much carbon their products are going to be using. Yeah, and what then can be done. Yeah. So, and if they can ensure their product is kind of using less carbon over its lifetime, maybe they can be incentivized, yeah, they can be given some benefits, yeah, okay. And there could be circular economy for hardware, yeah. I gave you the example of Rolls-Royce, yeah, jet plane engine. So there could be those kind of things, yeah, making the things that last long and then creating a circular economy around that, yeah. So creating economy around more, you can say, refurbishment, remanufacturing, recycling, more around it. I think this one in the middle is at the moment missing, yeah. Anything goes wrong, it's a waste, yeah. Okay. So now you know, like we looked like sustainability, security in a kind of two distinct aspect, right? But these things has to be considered together, yeah. So there is always an interplay between security and sustainability, yeah. So you should do secure updates and extend device lifetime as well. So this is kind of, you know, if you try to kind of meet one metric, you kind of negatively impact other, yeah. So if you try to make things more secure, it turns out it's less sustainable, yeah, because you need kind of extra hardware, or you need extra software, or maybe tens of software to monitor things, but then that's all burning power, yeah. Extra hardware is like using extra material, and that is not helping sustainability, yeah. So try to do in a way like if you update, make sure maybe it extends the lifetime as well, yeah, somehow, okay. And here second point says power, you know, in our computer or phones there is a power operating mode, yeah. So when nothing is happening, like higher level power mode, but if it is a compute intensive game running, it's the highest power mode, okay. But using that you can say feature to get some sensitive information, yeah. So it's like if it's running at that voltage level, they use to transmit some information, yeah. Later on I will show you like how this kind of power labels can, so they do in a way like, you know, they will kind of they will change the frequency of the processor in a way low frequency, that means bit 0. So they will put an extra program that is going to control the frequency. If it's low, frequency, and then that's bit 1, then again they lower it, and then kind of this they keep doing and then release the power, yeah. Just like when nothing is happening, put in low power, but they can take control of this feature and can send sensitive information. And also secure supply chains enable ethical sourcing, okay. I think that's not much to discuss. I think some of you also mentioned you are interested into AI, and AI is very good, and if we want to kind of have joint optimization of security and energy, yeah. So you already have seen the Google data center, yeah. They reduced their energy bills or cooling cost by 40% by having this AI driven cooling, okay. So it's like there are a lot of requests from all the world is coming to one data center, which server, which node, what should be the operating frequencies so that they don't take a lot of power, okay. All right. Introduction of secure and sustainable computing, and we need to have tailored solutions to scale and context. So what is the scale? Like it is embedded device, it is maybe just a camera, yeah. So we should think of a solution that is just for that camera, yeah. So scale, and in the context as well, what exactly it's doing, yeah. So what it does, what is, how big or small it is, we should think the solutions in the same way, yeah. Like I said, we don't need, children can have different class of smartphones, older people can have different class of smartphone, yeah. Not everyone needs to have those, okay. And adopt emerging technologies and best, something like patching and upgrading and all those things, yeah. And whatever best practices are developed, we should always adopt. Okay, any questions? No? Easy, yeah.
Told about the solution that we can implement AI to
Cooling.
for resource management kind of thing.
Yeah.
Just to run that AI.
So there is a trade-off, yeah, but you always use some mechanism, yeah, to, yeah. So for example, in our smartphone, when you run different applications, it runs onto some so there is no AI based approach because it's not best, yeah. There is something called like scheduling or governor. It defines the policy at some place, for example in data centers, yeah.
In data centers where we have lots of features from we have to decide.
Yeah,
We'll be needing another kind of.
this is, yeah, I think this is kind of, effort, yeah, and you have to see whether in long run it can pay off. So there can be some situations it can pay, okay, interesting, yeah. So I think, yeah, the yeah, you have to find the situation where you can use AI, okay, yeah, it's not useful. In smartphones, my group developed some, you might know, reinforcement learning, yeah. Reinforcement learning has again lots of ways to do, right. There's one like Q learning, yeah. Okay, so you develop some Q table. We developed something for applications, but it takes a very long time to learn, yeah, the best decision. It never finds the best point. So the something more heuristic based approach of these, just to show like where this kind of learning based approach is good and where it's not good, okay. But there is again a problem. If you do your research these days, you might have seen you are not following the trend or something, yeah. So you have to basically do some results, yeah. You have to show the results, like result. So I will not choose for this specific scenario, yeah. So what I'm saying, if you do just do heuristics or some typical approach, yeah. So it's better to have some AI approach and just show how bad it is, yeah. That, yeah, because they do project for some kind of government organizations as well, yeah. Hospitals or maybe this defense sector, yeah, they also use data centers. So won't be sharing the same thing, yeah. Yeah, I think some of the things are very be shut down, yeah, like there is always kind of insider threat or something, so someone from inside may tamper or something, so I think for that purpose, yeah.
Like for sustainability and energy like conservation, wouldn't it?
Yeah, it's interesting. This guy Oracle, yeah, who opened this company Oracle, yeah, Larry Ellison, yeah. So he said, why don't you use big data centers, do everything there, and these computers can be just terminal. I mean, Microsoft has like their own market, yeah, PC, and PCs were expensive as well, and now you can see these kind of things are happening, yeah. We are putting lots of file on the cloud, and then just doing like remote centrally, and then kind of do logging. Everybody gets kind of access. Is the amount of sensors, yeah, amount of IoT devices or embedded devices, they are much. Data centers are in thousands, and in future there are going to be more and more IoT devices and less data centers.
Wi-Fi router can have that kind of mechanism.
Yeah, so this is where the trend is going. It should be more and more local processing data to be sent on the cloud. So I think there is already prediction, like if you look, I think by 2030, yeah, so there will be huge amount of devices, and if you send all the data to cloud like we are sending now, cloud will not have enough processing capability. So around 80% of the data, 80% of the data has to be processed locally by 2030. That is why this edge processing, edge computing trend is coming. So one thing is abundant amount of data from all these devices, yeah. Another reason is basically security, you can say. Nobody relies on, I mean, although every company says you are end to end protected, your data is safe, your processing is safe, but everybody is developing their own edge computing facility, yeah. Yeah, I think it's kind of all driven by how much data is going to be flowing and how sensitive the data is, yeah. Good
But
discussion.
like I was just asking about for security purposes, if we are processing a lot of stuff in everyone's phone, there are some general you know trying to do exploitation and stuff. So rather than calculating in everyone's phone, it would be better if we implement it directly on the router or the system from where we are connecting the network.
Yeah, it can be. I think there is always a reason, like it's more kind of sustainable, you can say, but there could be security challenge. Now it's like there is like a centralized place where all the information is going, yeah. If someone gets access of that, then everything is going to be corrupted. Not everything will work then, yeah. So if there is individual, like one gets compromised, other can still work, yeah. So I think anything that goes like centralized processing, yeah, it's called something like single point of failure. If anything wrong happens at the central point, everything connected to it goes wrong, yeah. Yeah, it could be, maybe you can have multiple routers, yeah, maybe.
That function would work there.
Yeah, yeah, I mean there people have proposed like a distributed way, yeah, like this many set of devices with this router, and if it's compromised, maybe all of them can connect to something else. Yeah, I think these are all the ideas and kind of approach. Yeah, I think again that is like edge computing. Yeah, like I said, there are lots of cameras maybe in this campus, right? And they send all these feed to a server. Yeah, that is edge processing. Yeah, and then the results are there, and then they may send back the information to these cameras if they have maybe some voice or something. Yeah, they can alarm something or something like that. Yeah. Okay. Okay, that was my last slide. Any more discussions? Very interesting discussions. Yeah. Like I said, yeah, I showed you 5 metrics. Yeah, performance, energy, temperature, reliability, security. If you want to make one thing better, rest goes wrong. Yeah, yeah. So if you want to optimize for energy efficiency, we should have just very small computer. Yeah, but then you can't do everything. You can't secure it. Yeah, you can't achieve the performance you need. So this is the problem. We have to basically balance everything. Yeah. Okay. That's why I say sustainability is basically to balance energy efficiency with the planet. Yeah. Okay. And security, I said, is basically balancing or ensuring that CIA. Yeah. Confidentiality, integrity, and trust. Sorry. Yeah. Availability. Sorry. Integrity and trust and availability. Okay.
Excuse me, sir. I have one question.
Yeah.
Sir, on account of sustainability, as you said that by data offloading, we are reducing the energy consumption of this data center, right? At the same time, when we think in the reverse manner, increasing this edge devices is more like causing that e-waste, right? More. So, what do you take on that one?
I think it's interesting again. So you see, we saw some statistics, like we say around 4% of electricity is going into electronics. Yeah, out of that 3% is in data centers. Yeah, and 1% is in all the edge or sensors and everything. Yeah. So I think because they are already taking a lot of power. Yeah, and these edge devices take less power, and that one is taking a lot of power because all the data from these edge devices is going there. Yeah. So to me, it's always better to do as much local processing as possible. And also in future, we will have many more edge or IoT electronic devices. Yeah, than the centralized data centers. Yeah. So it's better basically to do as much local processing. Although, like I see, these are like maybe increasing by 1 billion. Yeah. Every year or every 6 months. Yeah, and data centers are increasing maybe just 1,000. Yeah, but if you look like the kind of power supply they consume or the number of electronics they use, and like they use big chips, right, not small. So still these edge ones should be very much comparable. Yeah, I mean maybe less. Yeah. Okay. Yeah. Okay, good. Yeah. Anything else? Okay, if not, we can break now. I think it's a bit early. Yeah, I said 3:15 or 3, right? Yeah. So you can take longer break. Yeah. And then you have the next lecture at 4. Okay? By Dr. Momita. Okay? And she will cover network security. Yeah. So I have not covered network security. Yeah. And in my next lecture tomorrow, I am going to cover more on what I introduced. Yeah. Like I said, if you start with a bad hardware, yeah, that means someone inserts some trojans or some circuit that will start malfunctioning after a year or something, what it can do, yeah, and how that can be detected, what can be the mechanisms to stop it. Yeah. So those kind of things, and how we can use different kind of side channel properties. Yeah, like I said, how we can use sound, how we can use temperature, yeah, or how we can use the timing information to kind of get some sensitive information. So I will briefly introduce these approaches that we have developed in our group, and also some from other groups as well, and then how we can basically detect and mitigate. Yeah, and I think we also have the sustainability methodologies as well. So again, I will talk again in my group what we have developed to do in terms of energy efficiency, achieving energy efficiency in data centers or in your phone, in your laptop, all these things. Yeah, okay, more details. Yeah, okay, all right. So you are free now. Yeah, I think you had very short lunch, so you can have extra lunch now. Okay.